Today we're talking about comparing functions, and we're going to be doing a ton of comparing using the slope. So remember, the slope is the constant rate of change, and there are several different ways to find slope. If you're given a t-table, then you might want to find the change in y over the change in x. If you're given a graph, then you would want to find rise over run. And if you're given two ordered pairs, you would want to use the slope formula, which is y2 minus y1 over x2 minus x1. All of these three methods will give you the slope or the constant rate of change. So let's look at this first one. It says determine which function has the greater rate of change. In other words, which one has the greater slope, because rate of change means slope. So on the graph, we're going to use rise over run. Doesn't matter which point you pick. First of all, I like to see that this slope is positive. So I'm going to go ahead and make a note that it's positive. And then I'm going to rise up 1, and I'm going to run over 1. So this slope is 1 over 1, which reduces to 1. All right, now let's look at the t-table. For the t-table, I'm going to use the change in y over the change in x. So I'm going to look and I'm going to say, okay, what is the change in y? How do I go from 0 to 1? I add 1. From 1 to 2, I add 1. From 2 to 3, I add 1. So the change in y is 1 because that's what I'm changing each time. For the change in x, I go from negative 1 to 0. That's adding 1. 0 to 1 is adding 1. 1 to 2 is adding 1. So the slopes are the same. They both are 1. So these have the same slope or the same rate of change. Okay, determine which function has the greater rate of change. Oh, and I forgot to mention on this first slide that you can also pick slope out of the equation y equals mx plus b. If you have an equation written in slope-intercept form, then m, or the coefficient with x, is your slope. So let's look at that. Since this equation is written in slope-intercept form, the number attached to x, or the coefficient with x, is your slope. So the rate of change here is 1/3. And now let's look at the t-table. For that one, I'm going to use the change in y over the change in x. For the change in y, I go from 4/7 to negative 0.25 to 0 to positive 0.25. So this is a bit crazy, right? 4/7, let's see what that is in the calculator. To go from negative 0.25 to 0, you would add 0.25. So for these three steps, you would be adding 0.25. But let's see if we go from 4/7 and we add 0.25 if we get a negative number. There's no way that would work. Right here, the pattern doesn't work. It does not have a constant rate of change. And since this doesn't have a constant rate of change, there's no way that you can compare the rates of change because the table doesn't have a constant rate of change. So you can't compare them. I think maybe in Connexus it'll say like none, or I'm not sure, but you can't compare them because this one doesn't have a constant rate of change. Determine which function has the greater rate of change. Okay, so for the graph, we're going to use rise over run. I'm going to start down here and I'm going to rise up 2 spaces and I'm going to run over 1 space. So my slope is 2 over 1, or 2. And then over here we have, as x increases by 1, y increases by 3. So remember, if we're looking at rate of change, we want the change in y over the change in x. So the change in y, it increases by 3, and the change in x, it says it increases by 1. So this blue one, or this statement here, has a greater rate of change because 3 is greater than 2. So in this case, this one has the greater rate of change. Determine which function has the greater rate of change. All right, so we're starting with a graph. So we're going to use rise over run to find the slope or the rate of change. We're going to rise up 1, and we're going to run over 1, 2, 3, 4. So my slope would be 1 over 4. And then down here we have an equation. And remember, when you have an equation in y equals mx plus b form, the slope is the coefficient of x, or the number attached to x. So if we look down here for our number attached to x, the number that's attached to x is 0.25. And we're trying to see which of these rates of change is greater. Well, I don't know if you noticed, but oops, that's not my calculator. 1 divided by 4, or 1/4, is 0.25. And if you didn't know that, you could come over here and just do it in your calculator. 1 divided by 4, it equals 0.25. So both of these have a slope that's 0.25, so they are the same. Mario's dog has 3 puppies, Archie, Bailey, and Coco. Mario measures the weight of the puppies across several months. Then he represents their weight as a function of time. In all 3 functions, y represents each puppy's weight in pounds, and x represents the time in months. So Archie, we have this graph. For Bailey, we have the slope-intercept equation. And then for Coco, we have a t-table. And the question is, which dog gained weight the fastest, or at the fastest rate? So we have to find the slope of each and see which one is bigger. So I'm going to start with the slope of the graph, and we're going to, I don't need to write it on top of the graph. We're going to be using rise over run to find the slope of the graph. So you can start from this bottom point and go all the way up to the tippy top point if you want to, or you can just go to like the next point. I think going to the next point is the easiest. You rise up 1 and over 1. But if you went from the point it gave, so you could go from 2 to 14, so you would rise up 12, and then from 0 to 12, so you would run over 12, and 12 over 12 reduces to 1. So either way you find the rise over run, the slope of Archie is 1. He's gaining 1 pound per month. I'm going to go ahead and write that here. 1 pound per month. Okay. Now let's look at the slope for Bailey. Remember, in an equation in slope-intercept form, the slope is the number attached to x. So Bailey gains 3 over 2 pounds per month. And you might be like, well, what is 3 over 2? Let's go to our calculator and turn it into a decimal. So we can do 3 divided by 2. That's 1.5 pounds. It makes a lot more sense in the real world to say 1.5 pounds than to say 3 over 2 pounds. So let's write that down as 1.5. So he gained 1.5 pounds per month. That's his unit rate, or his slope. All right, and then for the table, remember we can use the change in y over the change in x. So our y's go from 4.5 to 9.5. And if you don't automatically know that you're adding 5, you could always find the common difference. And the common difference says to subtract. So 17 minus 12 is 5. This is interesting. So let's go ahead. 4.5 to 9.5, you're adding 5. From 9.5 to 12, let's see. We have 12 minus 9.5. Oops. What is happening here? That only goes 2.5. So that's interesting, but let's look at the change in x. This part adds 4 from 2 to 6. From 6 to 8, it adds 2. And then from 8 to 12, it adds 4. So this actually does make sense. For a second there, I thought that it wouldn't have a constant rate of change. But for every 4, well, let's just put it in here. The change in y, for every, if you change the y 5, you change the x 4. And you could also write that as you change the y 2.5, you change the x 2. Either way is fine. If we do 5 divided by 4, that says that he gained 1.25 pounds per month. And if we did the 2.5 divided by 2, oh my goodness, what is happening here? 2.5 divided by 2, it would tell us the same. So the constant rate of change here is 1.25 pounds per month. So this dog is increasing 1.25 pounds per month. So which dog gained the weight fastest? Well, this was 1 pound per month, this was 1.5 pounds per month, and this was 1.25 pounds per month. So Bailey gained the weight the fastest because his increased by 1.5 pounds per month. I actually want to go back now and check this to see if, yeah, no, that still doesn't work. Okay, I just wanted to make sure. All right, I hope this helps.